Someday connection technology will catch up with the rest of our Hello, InfraCon. We're going to talk about improving transaction visibility in wallets. And if you've ever used a wallet and executed any transactions, you probably understand that the current experience is not exactly what you might wish it was. So a couple examples of that. Here's a screen, there's a bunch of info here. This data is right, it's true, it's accurate, but it's also not very useful. The last time that I opened up my wallet and I wanted to look at all of the details, 15 pieces of info about the gas that was used on the transaction was basically never. What I wish I had was one simple piece of information that actually told me something that I wanted to know, which is what in the world did this transaction actually do? Likewise, if you've ever gone back in your transaction history to try to figure out what you were doing a month ago, 2 months ago, and you see all these transactions and you're like, what was I trying to accomplish here? What you're gonna end up doing is clicking every single one of these transactions to get into the block explorer and then try to remember what each thing was as you go to the next one to figure out what you were working on. What you really want is something like this that just says, look, here are the things that you were doing. You don't open up your bank account and then have to spend 10 minutes trying to figure out each transaction and like what the gas was and all these details, right? We just want something simple. Okay, so why does Noves care about this? We believe that blockchain is going to change the world for the better. That it's going to bring about a lot of changes that are going to have a positive impact for people by reducing waste, by cutting out all kinds of fees of slices of value that are taken out by people that aren't adding anything, and by reducing corruption through transparency. With the result is that we can take the resources that we have and we can direct it towards stuff that matters, towards people that need it, towards things that can actually make a positive change for humans. But in order to get there, we need the tech around blockchain to change a lot. We've got great core technology, but it's inefficient, it's difficult to use, it's hard to understand what happened, it's hard to work with. In order for us to achieve the promise of what blockchain can bring, we need to make a change to those things. So Noves is the semantic layer for blockchain data. What that means is that we translate low-level data into information, into something that has meaning, that's categorized and tagged, that people can work with easily without having to spend all their time sort of slogging through low-level data. So we spend all of our time, our whole team spends all of our time digging through transactions, trying to understand what happened, and working on building solutions that make that easier. So this is kind of what we live and breathe. All right, so back to the problem. So why can't we have nice things? Why do we have this problem? The reason we have this problem is because people keep building new things. All of you keep building new things. And every time you build something new, the old data structures, the old systems, whatever someone did before doesn't work. And so you have to build some new way to hold that data, new objects, new data structures, which is great, but it creates a problem on the back end for people that are trying to work with that data. But it shouldn't be that hard, right? I mean, we can see you go into a transaction, you've got an event, it says it was a swap, so how hard can it be to figure this out? We've got all of our fields that we need. But like most things, that simplicity sort of hides a larger complexity that sits underneath the data that you're looking at. We're going to look at some examples here. All right, so this is a basic swap transaction. You don't have to read all the details there. What we want out of this is, we want something that says, look, I swapped 71,000 CVX curve for 69,000 curve, because that's what happened here. And that's really what I want to know, even though I've got this whole screen full of data. So where's this going to come from? If we look at the function, it's called exchange. The way we work with our systems, we start by identifying what the purpose of a function is, and then everything else follows from there. So here, we'd identify that exchange is actually a swap, so that gives us the beginning of the description, the swapped portion. And then to pull the value, we can go into the transfer events. So a swap like this, there's going to be two transfers. There's one from the wallet who's doing the swap, of what they paid, and there's one transfer of what they received back from the AMM in this case, right? So here we've got the value of what they swapped, and then this address that's in that Transfer event tells us what they swapped, so that tells us that the token they sent, this is the address here for CVX curve, and then there'd be a transfer going the other way, which would tell us what they received back, the 69,000 curve. So that's pretty easy. Sometimes it's a little bit less easy, so this is also a swap transaction, but this time, instead of 4 events, there's 13 events in here, and this is likely it's an aggregator, so this is Firebird's aggregator. At the end though, I still want the same description. I don't care about all that complication, I just want to know I swapped Hope for WBTC, and I just want to get that back from this. So to get to that, here we've got a different function. This again is pretty easy to identify. Swap exact tokens for tokens, it's a swap. And then we have the same thing, we've got 2 transfers in and out. So the same as we did before, we can pull the value, and then this 0xD78, that's the address for the Hope token. So that was also fairly easy. For this transaction, it's a little bit more interesting. So this is a limit order. What makes this one interesting is that the address that initiated the transaction, the sender of the transaction, is not actually involved in the swap, right? So this 0x91 is the address that initiated the transaction, and this 0xB58 is actually the one executing the swap. So that wallet previously logged a request for a limit swap, and now it's been executed by some kind of probably a keeper or some other sort of automated process. So to get to our description that we want to have, because again, same as our first 2 transactions in the wallet, we want to see the same text, the same description to tell us what happened. So here, our function name is settle orders, which is a little bit less clear that it's a swap, but in the context of the contract that this is, settle orders is how those limit orders are resolved. So we can map that into the swap description again. And even though this was initiated by a different address, in the transfers, which you can see here, both of the transfers are from and to the wallet of the person that entered the limit order, right? The transfers don't go from or to the initiator. So once again, there's only two events for us to deal with here, the in and the out, and we can map those into the 2 tokens that we have here. Sometimes we get into situations that are a little bit more complicated. So this transaction, you can see that there's a whole bunch of tokens transferred. But even worse, when we get to the function that was called, here we have a multi-call. So multi-call, for those of you who don't know, it's basically a way for a contract to execute a series of calls instead of just a single function. So multi-call lets you say, hey, I want to run this function, then this function, then this function, then this function. And so unfortunately, we can't actually map this function name because it could be a swap, but it could be anything. It could be anything on any contract. So in order to figure this one out, we have to dig a little bit deeper. This is what the data looks like on the top left here. So here there are 3 different commands. These 3 lines in the data are saying I want to run 3 separate functions. And if we decode this middle function, we can see that the method that's actually being called is exact input, which is a brilliantly named swap function on Uniswap v3. So if we take all 3 of these, 2 of them are swap exact tokens for tokens, and 1 is exact input. All of these are swap functions. So this multi-call is just calling swap, and then swap, and then swap again. And if you add up 3 swaps, you have a swap. So that gets us back to our text description here for swap. And just like all 3 of our other examples here, we, at the end of the day, we only have 2 transfers, 1 in, 1 out, and those we can use to pull our values. Okay, so we have one more example here that puts a little bit of a twist in this. So in this case, it looks like a simple swap. We swapped some crow for this other token. We can pull the function name from swap ETH for exact tokens. But when we get in here to get the value, we've got a mismatch. So we sent 26.29 crow, but we only actually paid 26.16 crow. And this is kind of a special case we have in EVM where if you want to pay if you want to swap in an AMM with the native coin, you have to send the full amount, the maximum amount that you are willing to pay. If you're swapping a token for a token, the AMM can pull from your wallet the amount that it needs for the swap, but in this case you have to send the full amount. So what happened was we sent $26.29 because that's what we were willing to pay, but in fact we got a better price at the end of the day, and so we received a refund from the contract of the additional amount that we didn't have to pay in the swap. And so in order to get to our actual price that we paid when we built a subscription for this, what we would do is we take the amount that you sent, we find that refund that you got, and then we subtract that to give you the actual total that you received. So that's how we get to this number. All right, so for swaps, just in the examples we looked at, these are the 5 different function names that we saw, and there are many more because of course anybody can create a contract that calls their swap function anything that they want. I want to take a quick look at a few NFTs because there's some interesting scenarios here. So here's an NFT transaction. You can see in the bottom, kind of the summary part here is that an ERC 721 was sent from one wallet to another, so it was basically a sale through a marketplace. And this is a type of description we might want to have that you would see in your wallet. Bought Izanami's Cradle number 1448 with the price. And that looks great if you are 0x1D. In other words, if you are the person who received the NFT in this transaction, this is a great description for what you want to see in your wallet. But if you are 0xC27 and you were the one who sold this NFT, this is not going to make a lot of sense for you in your wallet history if you see that you bought an NFT, because in fact you sold an NFT, right? So for the same transaction, depending on who you are or which wallet you own in the transaction, we want to display a different message to the user that's actually meaningful based on their context. So here we would say that this is sold. This is an NFT that's sold. And in fact, in this transaction, there are other parties that are involved. So if you are this address, you are actually the creator of this NFT. And so what you would want to see is that you received a royalty in this transaction because you didn't buy or sell it. And in your wallet, it's not going to make a lot of sense to you if you see a buy or a sell. So for us, when we process transaction data, we always process data with a perspective of a particular wallet, and then we output the descriptions and the rest of the data relevant to that particular wallet. Just as a bonus thought for wallets, ideally I think we would all like to also know what a transaction is before we sign it. It's great to tell you what contract you're sending it to and give you a dump of the hex, but it'd be really nice if we could just get a simple text description that says, hey, this is what this transaction is about to do.